Hey Algebra 1, this is Mr. Biney coming at you with our second day of notes. So today we're going to be working on actually graphing our quadratic functions. So the first thing we're going to look at is we're going to find our vertex and axis of symmetry, just like from the last notes. So our first step, we have to find the axis of symmetry first, because we need that to find the vertex. So our axis of symmetry, if you guys remember, is going to be negative b over 2a. And then just a quick reminder, so every equation is going to be in the form y equals ax squared plus bx plus c. So in this particular equation, our a is going to be out whatever's out in front of the x squared, which is just 1. So our negative b over 2a is going to be 2 times 1. And our b is going to be whatever's out in front of just the x, which is negative 6. So we have negative 6. So that turns into, because we have a negative 6, it's going to be a positive 6. Over 2 times 1 is 2. And 6 divided by 2 is 3. So our axis of symmetry is going to be x equals 3. So that's the line that we'll be able to fold our parabola in half over, and it should be symmetric. So if I draw that in, we go over to 3, and this line isn't actually part of your graph. I'm just drawing in the little dashed line just to show you guys where that's at. So then next we can find our vertex. So to find our vertex, all we're going to do is plug in the x value from our axis of symmetry into the equation and see what we get out for our y value. So if we plug that in, we have 3 squared minus 6 times 3 plus 4. So if we keep going to solve that, 3 squared is 9. Negative 6 times 3 is minus 18 plus 4, which should equal 9 minus 18 is negative 9. Plus 4 is going to put us at negative 5. So our vertex is going to be the point 3, negative 5. So that's going to be 1 point on our graph. And if you guys remember from the last notes, the vertex should be on the axis of symmetry. So if you see that red dot is our vertex, is right on that dashed green line, which is going to be our axis of symmetry. And then our last step is we can make a little table and find some more points so that we can actually graph it. So we make an x row and a y row. So we're always going to we'll start with the vertex is going to be one of our points, so that x value is 3. And then we're going to go 2 points to the left and 2 to the right. So 1 to the left is going to be 2, and then 1 more is going to be 1. 1 to the right is going to be 4, and 1 more is going to be 5. So we plugged in 3. We already know we got negative 5. Then if we plug in the rest, if we plug in 1, we'll get 1 squared minus 6 times 1 plus 4. And that's going to equal, we have 1 squared is 1, minus 6 is negative 5, plus 4 is going to give us negative 1. And if we plug 2 in, we'll get 2 squared minus 6 times 2 plus 4. So 2 squared is 4, and 6 times 2 is 12. So 4 minus 12 will put us at negative 8. Plus 4 will leave us at negative 4. So that's going to be our y value for 2. Then if we plug in 4, it'll be the same process. Just plug it in for x. Four squared is 16, minus 6 times 4, which is 24, will put us at negative 8. Plus 4 is negative 4. And then if we plug 5 in, we have 5 squared minus 6 times 5 plus 4. So 5 squared is 25, minus 6 times 5 is 30, which puts us at negative 5, plus 4 leaves us at negative 1. Then each of those is an ordered pair, so we can graph those. So we have the point 1, negative 1. That'll be right here. We go 1 to the right, down 1. We have 2, negative 4, so we go over 2, down 4. Then we have 4, negative 4, and 5, negative 1. So if you see, these points should line up right across from each other, the same distance away from the axis of symmetry. And then we can just draw our parabola. And there you have it. That's how you graph a quadratic function. So if we move on to the next example, we're going to start the exact same way. So we'll start by finding the axis of symmetry, which is x equals negative b over 2a. So here our a value is negative 2, and our b value is positive 10. So if we go back in, we have negative 10 over 2 times negative 2. Then if we simplify that, negative 10 over negative 4, we should get 5 halves. Then we can find our vertex. So we're going to take our x value that we found, our 5 halves, and plug that back in. So we have y equals negative 2 times 5 halves squared plus 10 times 5 halves minus 3. So if we simplify that, we'll get negative 2 times 25 over 2 plus the 10 and the 2 will cancel. So we can make that 10 to 5 if we divide both of them by 2. So then we'll get plus 25 minus 3. And you can plug that into your calculator if you want, but it should come out to be 15.5. So then our point is going to be 5 halves (15.5). So if we go over to our graph, 5 halves is the same as 2.5, so that's where our axis of symmetry is going to be. And then our key point is going to be 5 halves, 15.5. So if we just kind of go off our graph, we have 10, 11, 12, 13, 14, 15. So 15.5 is going to be a smidge above that right there. That's going to be our vertex. So then if we make another XY table, doesn't matter if you make it going up and down or sideways. Either way is fine. So if our vertex was at 2.5, we can just plug in even numbers to make that a little easier. So we can just plug in 1 and 0 on either side of it, and then 3 and, or sorry, because we went all the way to 1, we'll go the same amount away. So we'll go to 4 and then 5. So if we plug in 0, we'll have y equals negative 2 times 0 squared plus 10 times 0 minus 3, which will leave us with minus 3. If we plug 1 in, we'll get y equals negative 2 times 1 squared plus 10 times 1 minus 3 will leave us with negative 2 plus 10 is positive 8 minus 3 leaves us with 5. 2.5 we figured out was 15.5. And then you guys can type these in your calculator again and plug in 4 and 5, but it should come out to be 5 and negative 3. So then we can plot each of those points. So at 1, it should be 5, over 1, up 5. At 0, we should be at negative 3. At 4, we should be at 5. And at 5, we should be back down to negative 3. So then if we connect those points, this is a pretty steep one. And make sure you extend it with those arrows on the end. All right, then we'll just do one last example together.